In this video we are going to learn the one more important concept of partial differential equation, that is formation of PDE by eliminating arbitrary functions. Okay. The elimination of one arbitrary function from a given relation gives a partial differential equation of first order, while elimination of two arbitrary functions from a given relation gives a second or higher order partial differential equation. That is, in a given equation, if you found only one arbitrary function, then the first order partial differentiation is sufficient. If you found more than one arbitrary function, then you have to find all the second order partial derivatives. If required higher order partial derivatives also, then we are going to form the PDE. Okay. Now, solving the problem is similar to the previous session what you learned, that is just differentiate with respect to x and y partially and then simplify the equations to eliminate the functions. Okay, moving to the first problem. Form the PDE by eliminating the arbitrary function from z is equal to f of x square minus y square, they are asking. Consider the given equation as number 1. Differentiating equation number 1 partially with respect to x, we get dou z by dou x is equal to f dash of x square minus y square, that is differentiation of f is f dash into differentiation of x square minus y square is 2x, y is a constant, it will vanishes. Okay, this will implies dou z by dou x is nothing but p, since the given equation z is a function of x and y only, so I will use the standard notation p, that is equal to 2x into f dash. Now simplifying the value for f dash from the above equation, will get p by 2x, call that as equation number 2. Now differentiating equation number 1 partially with respect to y, we get dou z by dou y is equal to f dash of x square minus y square into differentiation of y square is minus 2y, and dou z by dou y is nothing but q, and simplify this expression, that is minus 2y into f dash. Further you simplify for the value f dash, that is equal to minus q by 2y. Now observe the LHS in equation number 2 and 3, both are same, equating the RHS. Now we'll get the final solution in the form p by 2x is equal to minus q by 2y, 2 get cancels and cross multiply, will get the final solution as p by plus qx is equal to 0. Okay, now moving to the next problem. Form the PDE by eliminating the arbitrary function z is equal to xy plus f of x square plus y square, asking. Similar steps. Given equation, consider that as number 1. Differentiating equation number 1 partially with respect to x, will get dou z by dou x is equal to differentiation of xy is y and differentiation of f is f dash into x square plus y square into differentiation of x square is 2x, and dou z by dou x is nothing but p and y plus 2x into f dash. Simplify this expression for f dash, will get p minus y by 2x, call that as equation number 2. Now differentiating equation number 1 partially with respect to y, and then using the standard notation dou z by dou y as q, and simplify for again f dash, will get the q minus x by 2y, call that as equation number 3. Again in the same steps what we done in the previous problem, LHS is same, equate the RHS. Okay, so we will get p minus y is by 2x, q minus x by 2y, cross multiply and 2 and 2 get cancels. Finally we will get py minus qx is equal to y square minus x square. Just I am transforming y square to other side, qx to this side. Now moving to the next problem. Form the PDE by eliminating the arbitrary function z is equal to x plus y plus f of xy. Okay, call the given equation as number 1. Differentiating equation number 1 partially with respect to x, will get dou z by dou x is equal to 1 plus f dash of xy into differentiation of x is 1 into y as it is. In the previous problem we have x plus y format is there, so the second constant will vanishes, but here x into y is there, keep the constant as it is. Just you assume that you are differentiating 2x like that. Okay, then In place of 2 we have y, just assume like that. We'll get f dash of xy is into y, and dou z by dou x is p 1 plus y into f dash. Now simplify this expression for f dash, we'll get p minus 1 by y, call that as equation number 2. So differentiating equation number 1 partially with respect to y and using the above logic, then we'll get the expression for q is equal to 1 plus x into f dash. Simplify for f dash from the above expression, we'll get q minus 1 by x, that is call that as 3. Again LHS is same, equate the RHS and cross multiply, we'll get the final solution as px minus qy is equal to x minus y. Okay, now the fourth problem. PDE, form the PDE by eliminating x, y, z is equal to phi of x plus y plus z. Okay, call the given equation as number 1. Okay, now differentiating partially with respect to x, keeping y as a constant. Remember, z is not a constant, z is always function of x and y. Okay, applying the product rule for x and z. First term x as it is, differentiation of dou z by dou x, z is dou x by dou z by dou x, and differentiation of x is 1 into z, that is equal to phi dash of differentiation of phi is phi dash of x plus y plus z. Differentiation of x is 1, y is 0, z is dou z by dou x. So using the standard notations, p for dou z by dou x will get y into xp plus z is equal to 1 plus q into phi dash. Simplify this expression for phi dash, will get y into xp plus z divided by 1 plus p, call this as number 2. Now similarly differentiate 1 partially with respect to y and keeping x as a constant. First term y as it is, differentiation of z is dou z by dou y plus differentiation of y is 1 into z. Differentiation of phi is phi dash into x is 0, differentiation of y is 1 plus differentiation of z is dou z by dou y. Use the standard notation dou z by dou y as q and simplify the expression for phi dash and call that as equation number 3. Equating equation number 2 and 3, that is LHS is same, equate the RHS parts, that is we'll get y into xp plus z divided by 1 plus q, 1 plus p, that is equal to x into yq plus z divided by 1 plus q. Cross multiply. Okay, now observe that xypq get cancels. Now group the terms containing p and q on one side and the terms do not containing p and q on other side, and take the suitable values as a common factor. Here I am choosing x and p as a common, and here y and pq as a common, here z is a common, so that we will simplify, we will get the final solution in this particular format. Now moving to the next problem. They are asking us to form the PDE by eliminating the arbitrary function from z is equal to x into f of x by y. Take the given equation as number 1 and differentiating partially with respect to x. Observe here we have two functions and both are functions of x, so I will apply the product rule here. First function x into f dash into differentiation of x by y is 1 by y plus differentiation of x is 1 into second term f of x by y as it is. Dou z by dou y is x is nothing but p, substitute that one, x by y into f dash of x by y plus f of x by y, call that as equation number 2. Now differentiating 1 with respect to y, we get here x is a constant, keep it as it is. Differentiation of f is f dash of x by y into differentiation of 1 by y is minus 1 by y square. Dou z by dou y is nothing but q minus x square, this x into x square by y square into f dash. Now from equation number 1, observe here I am just finding the value of f of x by y, transform the x to other side, will get z by x, and from equation number 3 find the value of f dash of x and transforming this minus x square by y square to other side, will get minus q by y square by x square. Substituting these in equation number 2. So in place of f dash use this particular expression, in place of f of xy use the z by x, and simplify that expression, will get the final solution as px plus qy is equal to z. Okay, moving to the next problem. Form the PDE by eliminating the arbitrary function from z is equal to x square plus 2 into f of 1 by y into log x, they are given. So call that as 1 and differentiating partially with respect to x. Okay, we get dou z by dou x is equal to 2x into 2 into f dash of 1 by y plus log x, and 1 by y is a constant, vanishes, differentiation of log x becomes 1 by x. So dou z by dou x is nothing but p, that is equal to 2x plus 2 by x into f dash. Call that as equation number 2. Now differentiating equation number 1 partially with respect to y, will get q is equal to minus 2 by y square into f dash. Okay, x is a constant, it will vanishes in the first term. Okay, and 2 into f dash, log x is a constant, vanishes, 1 by y is minus 1 by y square. Okay, from equation number 2 and 3 find the values for f dashes. Okay, and equate to the those two expressions, will get the final solution as px plus qy square is equal to 2x square. Okay. Now moving to the 7th problem, form the PDE by eliminating the arbitrary function from z is equal to e power x plus by into f of ax minus by. They are given. Take the given equation as number 1, differentiating partially with respect to x, we get, observe here, both are functions of x, apply the product rule, dou z by dou x is equal to e power, the first function as it is, differentiation of is f dash of ax minus by into differentiation of ax is a, plus differentiation of e power ax plus by is a into the second term f of ax minus by as it is. Okay, now dou z by dou x is nothing but q, will get a into e power ax plus by into f dash plus a into, observe this particular term, by using equation number 1 I can able to replace e power ax plus by into f of ax minus by as z. Okay, now differentiating equation number 1 partially with respect to y, again use the both are functions of y, product rule, first function into differentiation of second is f dash into differentiation of minus by is minus b, and differentiation of by is b into f as it is. Again for this particular term I will use the equation number 1, that is z. Okay, we will get minus b into e power x plus by plus f dash plus bz. Okay, if you observe the equation number 2 and 3, it's very difficult for us to eliminate f dash because the coefficient is here a is there and here b is there. So for that purpose what I will do is I will multiply equation 2 by b and equation 3 by a, and adding both the equations will get pb plus qa is equal to ab into e power x into f dash plus minus ab into e power ax into f dash plus abz plus abz. Okay, observe this particular term, plus ab into e power x into f dash minus ab into e power ax plus by into f dash get cancels, will get final solution as bp plus aq is equal to 2abz. Okay, now these are the 7 problems I given in this lecture videos. Work out all the problems carefully. Based on those problems you solve these assignment questions. Here I given the 6 assignment questions, so all are simple only is there. This is the first question is similar to the first one. Already we solved z is equal to f of x square minus y square. Similar to that we can able to solve. I think this is the 4th or 5th question. In place of y we have x, and here also in place of log x we have log y. Use the same logic over there, we'll get easily the solution. And what we done in the last problem, apply the similar to that logic. E power y into f of x plus y is there. Only with respect to y apply the product rule, easily will get the solution. And here L, M, N are constant, concentrating on eliminating phi dash, and z is a function of x and y, while differentiating with respect to x will become dou z by dou x, and with respect to y dou z by dou y, and these two is similar to the question numbers I think already we solved in this lecture videos. Use the same steps, easily will get the solution. Okay, in the next lecturer video we are going to discuss about formation of PDE by eliminating arbitrary functions. In this video I given only the formation of PDE by eliminating only the one function. Now in the next video I am going to give the formation of PDE by eliminating the two or more arbitrary functions. Thank you.